Imaging-related research in the Leitch-UW Multicom lab.
Okay, thank you. First of all, I have to apologize that I could not be here this morning because I had a commitment. So in the next couple of 5 minutes, I talk about the research related to imaging in the Leitch-UW Multimedia Communication Lab. So the lab was created with funding and sponsorship from the Leitch Technology in Toronto, also with great help from Toro Vanelli, who just left. So we have quite good facilities, and we got matched money from the CFI and other funding agencies. Okay. Well, I can summarize the imaging-related research activity in the lab probably in 1 minute. So that is, our research in imaging area focus on the compression, transcoding, watermarking, and some combinations. Okay, so let's look at a little more in detail. So in the compression area, we focus on both lossless and lossy compression. So we talk about we have some result, some theory for lossless image compression and lossless compression of high definition TV. So it turns out in early days, when people talk about compression, they always think about the storage, right? The speed, okay? So for STTV compression, some company actually have different interests. They want to, because the chip is not so fast, but the storage in the chip is quite expensive. So they want to compress, in this case, they want to compress the STTV signal in a lossless manner. In the lossy compression, we to research in both theoretic aspect and also the algorithm development aspect. So one part of this is focused on existing standards. So we don't change the existing standard. How can you develop the best encoder? Okay. So we have some of the examples. So in the lab now we have one of the best PNG and chief encoder. So without changing any syntax structure standard, we can achieve the best compression performance. Same thing can be said about the JPEG encoder. So without changing JPEG encoder, we can achieve the best compression ratio at same quality by using our own JPEG encoder. For the video coding, we work in both domains. So once the really theoretic exploration, you don't suppose you know constraint on standard, right? The second one is how they work within standards. So we have, I guess, one of the best H.264 video encoders. So H.264 video standard is pretty new. So that's for the compression. And for the transcoding, so the transcoding is really motivated by mobile communication. Like, for instance, you look at the standard definition TV signal and high definition signal. How can you translate one to this mobile device? Okay, so then you talk about different frame rate, different frame size, and even different quality. Okay, so once again, the transcoding can be divided into two parts. One is for image transcoding, the other one for this video transcoding. For the image transcoding, if you want to use a phone, cell phone, mobile device, to browse web page, right? You don't have to transmit this large image to your phone or to your mobile device. Okay. So once again, so the one problem you can see how do you do the efficient optimal image transcoding without changing image size and syntax, right? And well, there are a lot of process involved in this transcoding. The first one, certainly you need to reduce size. So then you can do the downsampling in the original pixel domain, but that's not efficient, right? So then the best way is for you to achieve the same thing by working in the transform domain. In this case, you can reduce computation complexity. Okay. This bullet actually is pretty new topic. I just thought about it. Well, so the John downsampling and compression. So, okay, 2 minutes. Okay. In early days, the downsampling and the sampling and compression are separated. So the key question is whether or not you have any gain if you combine the two processes together. Okay. So in the video transcoding, I talked about a little bit early before, because they have different more scenarios. So fix without changing frame rate, frame size, and the structure. How can you do that? Or you change some of the parameters. How can you do that? Okay. Let me show you some pictures. So if you look at this one, so that's the I call the transcoding without changing any syntax structure, frame size, no, etc. Okay. So somehow you just need to reduce the file size, okay, the bit rate, okay. So this is the JPEG compressor already, but somehow we can, if you find best trade-off between distortion and quality, then you the rate size you can further compress, okay. So you can different category, and this one is the actual time sampling. So we do the time sampling the transformer in this D domain, okay. Oops. The last one is the joint compression watermarking. So in early days, when people talk about watermarking, then they do not consider anything in the compression rate. But when I look at this problem, you can see that, well, if you want to protect your multimedia content, you want insert watermark in the content. But in the end, those watermark content will be transmitted or stored in the compressed domain. Okay? So there's no need for you to separate two processes. Okay? So it will be much more beneficial if you look at these two processes together. Okay? And so we have the, I guess one of the best, the joint JPEG compression and watermarking codec in the lab. So this is one of the example. So you can show this one is the JPEG compressed and watermarked. We do this together. So this one is the purely JPEG compressed. Okay? Actually, it turns out even though you embed this many bits into this picture, and the file size of this one even smaller than this, with same, the file size is the same, but the PSNI is even better than this one. Okay? So with this, I conclude my presentation.
David Cuff this morning was talking about the work being done right now related to Canada and the strong interest in image compression techniques. And they're using primarily focused toward JPEG 2000.
JPEG 2000?
How does JPEG 2000 stand up against compression techniques broadly? In other words, how much better per unit quality can be done?
Actually, if you look at that's a good question. So you go back to this one. If you do the joint optimization, the old JPEG can achieve the same performance JPEG 2000. But of course, at that time, people didn't know this joint compression technique. One motivation for people to adopt the JPEG 2000 is this kind of progressive property. So they have different resolutions. Yeah, in terms of the compression ratio, I think if you do the efficient, optimal JPEG compression, you can achieve the same performance.
Okay.
I'd just like to add something in terms of why we should use JPEG 2000 versus JPEG. Is that in many instances, JPEG Lossy is dealing only with 8 and 12 bit images, and many of our medical images are now 14, 15, 16 bit images, signed images, and we cannot convert them into 8 or 12 bits. So JPEG 2000 is much open algorithm and really allows us to deal with any depth of image. So that's
that's if you really use the standard soft code. If you want to develop your own JPEG, then you can do the same thing because you just do the different transform the same thing. So.
Questions back there?
You say you're developing this code. We read quite a bit of software in my lab. We love to embed some JPEG compression and decompression code. Where would be the best source of freeware or license-free compression code?
Well, I don't know. Actually, for the one I developed, we find the patent application is not free. So. Yeah.
David, do you know the answer to that one? Do you know the answer to where would be the best source, or what do you use in your?
we use commercial.
Commercial. Other questions? One of the questions that I'm sorry. Go ahead, David. I don't.
Yeah, I just wanted to know if you've been able to attack the watermark. If you do watermarking at JPEG 2000, or do you use JPEG?
So one of my students is working on that. So how to combine the watermark into the JPEG 2000 compression domain. Yeah.
Just one other question. You said you had a theory related to lossless compression. Or can you just talk briefly about that?
Well, I think the approach I take to the image compression and whatever any compression is starting from the theoretic foundation. So I want to develop something from the information theoretic point of view. It's not purely from the signal processing point of view. So like this entropy concept and the in the lossless case, and the rate distortion function in the lossy case.
Okay. Any other questions? Or?
Well, in the purely lossless case, like in the text compression, I have developed a new framework, the ground-based coding compression method. In the then I extend this framework to compression, loss compression image. At this point, we are pretty good for the bi-level image compression if I use the ground-based approach. Now we are still extend this one to compress any grayscale color image.
Okay. We thank you very much.